Amirul, I know you have a very bad marks for MAT 222. I can give you a free marks. Here, take this. Think about it.
Hey guys. Take your paper, candidate 1. Shoot. Candidate 2. Take your paper. Candidate 3. Take your paper. So today, you are the lucky few who are being selected for this to receive an extra mark for your subject MAT 222. But there can be only one winner. There will be 2 rounds. The first round will be Chapter 2 questions. The second round will be Chapter 3 questions. To determine the winner, and like I said, there can be only one winner. The one who wins or the one who did the fastest, and of course, it has to be correct. Candidate 1, Candidate 2, and Candidate 3. I wish you all the best. Your time starts now.
To answer this question, you must remember these 4 types of truth table. The first one is a truth table for negation, which shows the opposite true value of a statement, where the proposition flips its value. For example, the value of P is true and false, and negation of P is false and true. Secondly, the truth table of conjunction means that statement must be true for the result to be true. If either statement is false, the conjunction is false. For example, if the statement P is false and Q is true, or either way, the conjunction statement will be false. Thirdly, the truth table of disjunction means that at least one statement must be true for the result to be true. The result is false only if both statements are false. Lastly, the truth table of implication state that if P, the hypothesis, is true, then Q, the conclusion, must be true. The implication is always true if P is false, regardless of Q. Now you can answer this question. Now I can answer this question. Before I construct the truth table for this question, I must list all possible combinations for P and Q. For 2 propositions, there are 4 combinations of truth value. For P will be true, true, false, false, and Q will be true, false, true, false. To compute negation P for each row, negate the true step value of P, then it will be like this. To compute P implies Q, P implies Q equal to false only when P equals to true and Q equals to false. In all other case, P implies Q equal to true. Now to compute negation P and Q, it will be true only when both negation P and Q are true. Otherwise, negation P and Q is false. Lastly, to compute P implies Q and negation P and Q, I need to combine the truth value P implies Q and negation P and Q. The result will be true only when both are true.
Irshad, to answer this question, you need to understand these types of laws of logic. It states that if you negate something twice, you end up with the original statement. For example, negation P will be P. It describes how to distribute negation across logical operation. For example, negation P and Q is equal to negation P or negation Q, or in other way around. It tells us that the grouping of terms in a conjunction or disjunction does not affect the result. For example, like this. It shows how conjunction and disjunction interact. For example, like this. It states that repeating an operation with the same operand doesn't change the result. For example, P or P is equal to P and P and P is equal to P. It describes the relationship between a statement and its negation. For example, P and negation P is equal to false and P or negation P is equal to true. It shows the effect of combining a statement with true or false. For example, P and true is equal to P and P or false is equal to P. That combining a statement with certain value, true or false, results in a dominating value. For example, P and false is equal to false and P or true is equal to true. Describes the relationship between an implication and disjunction. For example, P implies Q is equal to negation P or Q. Describes how certain conjunction or disjunctions simplify. For example, like this. Simplify P and Q or negation P or negation Q or R using laws of logic. To do this, let's start by rewriting the question first. As you can see, negation P is in between two disjunction symbols. Therefore, we can apply commutative law, and it will be like this. And now, disjunction negation P, we can apply distributive law to P and Q, and it will be like this. As you can see, there is P or negation P. From this, we can apply inverse law. Therefore, it will be tautology, and it will look something like this. From this, we can apply identity law, and it will look something like this. As you can see, there is a disjunction negation P and disjunction negation Q. They both have the same disjunction, so therefore we can apply associative law, and it will look something like this. So now, Q or negation Q will be tautology
by using inverse law. Lastly, we can apply domination law since tautology or negation P or R.
To answer this question, you need to understand what is converse, contrapositive, and inverse. What is converse? Converse is a conditional statement that swaps the hypothesis and conclusion. For example, P implies Q's converse will be Q implies P. Note that converse is not always logically equivalent to original statement. The contrapositive is a conditional statement that negates both the hypothesis and conclusion and then swaps them. For example, P implies Q's contrapositive will be negation Q implies negation P. Note that contrapositive is always logically equivalent to the original statement. The inverse is a conditional statement that negates both the hypothesis and the conclusion but does not swap them. For example, P implies Q's inverse will be negation Q implies negation P. Note that inverse is not always logically equivalent to the original statement. Now you can answer this question. Now to answer this question, I need to identify the original statement. The original statement is if it's sunny, then I will go for a walk. This can be represented as P implies Q, where P is it is sunny and Q is I will go for a walk. Converse, I will swap P and Q. Thus, the converse statement will be if I go for a walk, then it is sunny. In logical form, Q implies P. For contrapositive, I must negate both the hypothesis and conclusion and swap them. Thus, the contrapositive statement will be if I do not go for a walk, then it is not sunny. In logical form, negation Q implies negation P. For inverse, I must negate both the hypothesis and conclusion but do not swap them. Thus, the inverse statement will be if it is not sunny, then I will not go for a walk. In logical form, negation P implies negation Q.
Oh, let me see. Come here, let me see. Candidate one. What? You are the one who to finish this first. And you did all correct. I'm impressed. This means candidate 2, candidate 3, stand up, rise. You all have been eliminated. Get out.
Candidates 2, candidates 3, join us. Now, round 2, chapter 3, same rules. You may start now.
Amirul, to answer this question, you must know forward-backward method. For forward process, you start with what you already know, facts or information, and move step by step to see what new thing you can discover. You keep applying rules or logic to your starting point until you get to the answer. For backward process, here you begin with the goal, the thing you want to prove or figure out, and work backward. You ask what needs to happen for this to be true. Then you trace back step by step to see if your starting information From the hypothesis and formula for the area of a triangle, the area of xyz equal to xy over 2, also equal to z squared over 4. By using the Pythagoras then, x squared plus y squared equal to z squared. On substitute z squared with x squared plus y squared and performing some algebraic manipulation, we obtain x minus y squared equal to 0. Hence, x equal to y and triangle xyz is isosceles.
The choose method is used in logic, especially in set theory when segments involve the universal quantifier for all. A set is a collection of objects called members or elements. In set theory, we represent sets using curly braces or set builder notation for larger or infinite sets. The choose method helps verify if an object belongs to a set. To do this, you select an object and check if it satisfies the condition that defines the set.
To show that S equal to T, it must be shown that S is a subset to T and T is a subset to S. To show that S is a subset to T, let S as an element of S. Consequently, x squared minus 3x plus 2 is less than or equal to 0, and so x minus 1 multiplied by x minus 2 is less than or equal to 0. This means that either x minus 1 is less than or equal to 0 and x minus 2 is greater than or equal to 0, or x minus 1 is greater than 0 or equal to 0 and x minus 2 is less than or equal to 0. X less than or equal to 1 and x greater than or equal to 2, or x greater than or equal to 1 and x less than or equal to 2. But x less than or equal to 1 and x greater than or equal to 2 is impossible. Therefore, x greater than or equal to 1 and x less than or equal to 2, which means that 1 less than or equal to x less than or equal to 2. Hence that S is an element to T. To show T is a subset to S, let T as an element of T. Consequently, and so T greater than or equal to 1 and T less than or equal to 2. Hence, T minus 1 multiplied by T minus 2 is less than or equal to 0. As example, T squared minus 3T plus 2 is less than or equal to 0. Therefore, T is an element of S. Hence, T is a subset to S.
To answer this question, you need to use construction method. This method is used when a conclusion involves an existential quantifier, such as they exist or such that. To apply this method, you need to reach conclusion that state there is an object with a certain property such that something happens. First thing first, you need to identify the object, its properties, and what happens to it. Secondly, you have to construct the object by using hypothesis to devise a procedure or algorithm. Last but not least, you have to show that the constructed object has the required properties and satisfies the desired outcome. On multiplying the equation, ax plus by equal to e by d and the equation cx plus dy equal to f by d, and subtracting the two new quantifiers, one obtains in brackets ad minus bc times x equal to ed minus bf. From the hypothesis, ad minus bc not equal to 0. Therefore, by dividing with ad minus bc, x equal to ed minus bf over ad minus bc. Similarly, y equal to af minus ce over ad minus bc. It can easily be checked that for this value of x and y, in brackets ax plus by equal to e, and in brackets cx plus dy equal to f.
Sir, ada dia. Wow, you got the question right. Congrats. Candidates 2, candidates 3, be gone.